amphibians and learn about monitoring the system for amphibians from Dr. Bill Gould. He's a biostatistician from New Mexico State University.
Thanks. Good evening, and thank you for coming to this last talk of the day. I appreciate you hanging in there with me. I'm here today to talk about the evolution of the monitoring program for amphibians that I've been involved with over the past decade. As a biometrician, one of the perks is I get to work with on a lot of different projects with a lot of different people. And it's been a pleasure for me to work with my co-authors. I've got Andy Ray, Kristen Legg, and Dave Tunman from the National Park Service. Blake Hosick is with the U.S. Geological Survey, and Deb Tatla is with the Northern Rockies Conservation Cooperative. If you're going to have a monitoring program, one of the first things you need to do is develop a monitoring protocol. And in that protocol, you better state what you're going to do, why you're going to do it, and how you're going to do it. So I went back to the Greater Yellowstone Network's monitoring protocol to look at what their original objectives were, and this is what I found. The very first objective is mostly what I'm going to talk about today, and it's trying to estimate the proportion of catchments being portions of watersheds, and wetland sites that are used for breeding by amphibians. Do that on a yearly basis and also estimate the trend of those. So there are a few things I want to point out here. First of all, there's different scales at which this is being monitored. So you've got a large scale at the catchment level. There are a lot of different wetlands within these catchments, so they're monitoring at two different scales. The second thing I want to point out is they're looking for evidence of breeding. So just the mere presence of individuals is not what we're looking at. We're looking at breeding presence. And the third thing I want to mention is that this is not a measure of abundance here. What we're estimating is really the prevalence or distribution on the landscape of breeders. And so the metric here is what's called the proportion of area occupied, and is being modeled using occupancy modeling, which is where I come in. They did have three other objectives in this protocol, and due to limited resources, they really haven't received that much attention. So this is an example of, you may start out with good intentions and have some good ideas, but in the end, the fiscal limitations might limit what you can actually do. And so I will talk a little bit about wetland drying toward the end of this talk, but for the most part, those other topics haven't really received the attention they probably deserve. So I mentioned the what, the why, and the how. I think of the how as the sampling design. How are you going to monitor populations over such an immense landscape as the Greater Yellowstone area here? Well, they identified over 3,500 different catchments within the two park systems here. And before I came on board, they developed a stratified random sample of 40 catchments from over 3,500 different catchments. I think they thought that was something that was potentially logistically doable in terms of trying to survey all those different catchments in a year, but again, there's a limitation as to how much they could do. There were two different kinds of strata that they used in that stratification. The first was a habitat quality measure at the catchment scale. So they had three levels of that: high, medium, and low quality, based on the amount of water in these catchments, the permanency of those water bodies, and so on. So that was one of the metrics that they used. And the other was whether or not those catchments were easy or difficult to access. And so when I came on board, they wanted me to evaluate whether or not these strata were useful in describing differences in occupancy, and if not, potentially they could remove, for instance, the difficult to access sites or collapse over the strata. So that was part of what I worked on from the beginning. I mentioned a sample size 40. In actuality, we measured 32 catchments really consistently over the decade that I'm going to be talking about. This is the beginning. This is 2006. And I hope you'll keep this in mind when you look at where we are now at the very end. In this case, I've got estimates of occupancy for three different species: salamanders, coarse frogs, and spotted frogs. And the blue estimates are what are called naive estimates. They're just a simple raw count of the proportion of catchments that had at least one water body where there was some breeding activity in there. So where I came along is I tried to adjust for imperfect detection probability in estimating and trying to find those breeding locations. And so normally, adjusting for imperfect detection would raise up those estimates of actual occupancy, but In the work I did, I also took into account the stratified nature of the design. Over 2/3 of the catchments are of low quality in this park system. And so as a result of that, they almost all had zero occupancy. So when you factor in the weight of all of those catchments that have low occupancy, that's what's bringing those estimates down. Those are less biased estimates representing the entire collection of catchments in that park system in terms of what the real occupancy levels are. So that's where we started. So now 2007 comes along. What are we going to do? Well, we could be like Homer Simpson here and not think at all. Just do what we've always done, which would be just estimating occupancy in 2007, the same way I did in 2006. I think even Homer might be able to draw a line between 2006 and 2007 to look at trend. So do you think we could be a little bit smarter than that? Think about the system a little bit. And, I think we can. And so what we thought about was, well, rather than just focusing on the trend, maybe we should think about what are the processes that are driving changes in occupancy over time. So that's where we initially began a multi-season approach to looking at occupancy. As a result of that, we really changed our entire set of models that we were considering. I think we had about 8 different models the first year I started analyzing this data. Most recently, I've looked at a model set. I've got a bucket of models of over 80 models in my model set, which is a lot of models to look at. But that's because we've made a lot of advances that I'll be describing. We've also made some improvements in terms of thinking about what are the covariates, what are the variables that might explain some of the dynamics of the system. Initially, we had some very basic measurements that were at the wetland scale. We've improved on that, as you'll see. So fast forward to 2010. Now I've got 4 years of data. I'm using multi-season models, as I mentioned before. Now we're looking at estimating colonization and extinction rates. And when I say colonization, I mean I'm referring to a site that previously didn't have breeding that has breeding in the following year. When I say extinction, I don't mean that everything's gone, but there isn't evidence of breeding there when there was before. And so we're looking at those rates over the 4-year period. We have new covariates, including at the catchment scale, the number of wetlands in the catchment, the interconnectivity of the spatial arrangement of the wetlands within the catchment, and whether or not that might affect some of those rates. There's a paper on this. I can't talk about all of the results and all the relationships, but I will mention a couple of things. One is that the catchment level estimates did show differences in those strata in terms of habitat quality. So high and medium quality catchments were very different in occupancy than the low quality catchments. But there essentially weren't any differences between high and medium quality catchments. So that's going to change how we do things in the future. The other thing that I want to mention is I wasn't very happy with the precision of the estimates. The variances were pretty big. The reason they're big is we're estimating a proportion, and we have a sample of 32. That's not a very big sample size to really have a good precise estimate. So it made me think that the wetland sites themselves might be more useful. We certainly have a lot more of them. We have 300 of them as opposed to 32. And site level results seem to be more interesting and dynamic. And you'll see that in this next slide. This is an example of that 4-year data set where now we have wetlands being classified either as permanent or seasonal type sites. And you can see that there's definitely a difference between those 2 different wetland types in terms of occupancy, which is estimated over here on the y-axis. But the more interesting thing is, look how the system is bouncing around among those 4 years. There's some things going on here. Let's try and figure out what those things are. What might be driving that? So I don't know who sent me this data set, but it gave me an idea of, hey, there's some other covariates that maybe we should be thinking about. Precipitation, snow and water equivalent measures. Are there other variables that we could be looking at to help describe these dynamics? So these outcomes generated new ideas, which made for more interesting changes. So first of all, we eliminated low quality catchments, which means we've really changed our population of inference. So we're no longer inferring to all catchments in the park system. We're going to infer to the medium and high quality catchments in the park system. Second, we've introduced some climate covariates. Precipitation is one of those, runoff, evapotranspiration, cumulative growing degree days. Those are variables that Dave Toma, one of my co-authors, he's the one that produces those estimates that allow me to do the modeling that I do with the occupancy. We shifted our focus away from catchments and toward wetland sites, and so that's really changed sort of what we're doing as well. So now fast forward to 2013. This is an example. Again, there's a paper on all the results. I can't talk about hardly any of them. But I'll give you one example of what I think is an interesting information that we've gotten from these analyses. So here I have estimated extinction rates on the y-axis as a function of runoff, and I have 3 different depths. So we moved away from permanent and seasonal wetlands to actual quantitative measurement of the maximum depth in the wetlands. And we fit a model that allows for an interaction between depth and runoff, and as a result of that, we have different slopes. So for those shallow sites with an average depth somewhere between 0 and 0.5 meters, the probability of going extinct in a very wet year is still non-zero, and it levels off at about 20% based on all the values of runoff in that year. Whereas for deeper sites, there's a much steeper drop, and if you have runoff of 600 or 800 millimeters, you almost have no probability of breeding going extinct in those sites. So there's a lot of interesting moving parts going on in these systems that we're learning about because we changed how we're doing things. But along the way, there's still things that I've thought about that I wasn't happy with. I'm not able to distinguish dry sites. So I'll go to wetland and it'll actually be dry. Well, there's no detection probability at those dry sites. They can pretty much tell there's no breeding, right? So I'd like to distinguish those from wet sites where they didn't detect breeding. I hadn't been able to do that before. It'd be helpful to quantify wetland drying over time. Pat brought that up several times. Why aren't we quantifying that? We should be measuring that. Great idea. Well, we've got a bunch of climate variables that could actually help describe some of that wetland drying over time now as well. We might even think about modifying those covariates and using lag values or using cumulative values to identify processes that are driving those dynamics. So now we fast forward to today. I've got 10 years of data. More data, more data. Statisticians love more data. So now I'm using what are called multi-state, multi-season occupancy models. And they're being used to jointly model the wetland drying and also breeding occupancy. They allow me to constrain the probabilities of detection to 1 for those dry sites and allow it to be less than 1 for those sites that have water. We have different parameters as a result of this new approach. We have a parameter which is the probability of a wetland being wet given its previous state. So the states in this multi-state model are it was previously dry, it was previously wet but didn't have breeding, or it was previously wet and did have breeding. So we're modeling that for wetland dynamics, we're modeling that for breeding occupancy of amphibians. And so that leads us to plots like this. This is an example of the probability of a wetland being wet given that it was dry in the previous year. Look at the variability in that system. 2007, 2010, 12, and 15, those are very dry years. So if you were dry in the year before, you're not going to be wet in the following year. The probability of that's pretty darn low. But in these wet years, 2008, 2011, 2014, that probability skyrockets, practically tenfold in terms of the likelihood of there being water. You got to have water before you're going to have breeding. So it's interesting to try and understand the dynamics of the wetlands to explain some of the patterns in the breeding. Now we've got an example of salamander breeding. Given the breeding occurred the previous year, here I've got the probability on this axis, and you can see that almost all of these are 50% or greater. So these sites are being used consistently over and over again. They're good sites. They've got breeding in one year. They're likely to have breeding in them again. Notice, however, in these wet years, 2008, 11, and 14, those probabilities seem to be a bit lower for salamanders. Something interesting in there that I hope the biologists will figure out because I don't know all of that. But we're going to talk about that. Breeding probability, given that the wetland was wet but didn't have breeding the previous year, is extremely low. There's very little chance that those sites are going to be colonized. Why is that? That's an interesting question. We probably should learn, try and figure out what's going on with those sites. To summarize, we have changed a lot in this program over 10 years. We've changed the target population that we're making an inference true. We've changed the sampling design from a fairly sophisticated stratified design to a simple random sample of high and medium quality catchments. We changed the scale of emphasis. We're really focused more on wetlands now rather than those catchments. And we've got a lot more to work with. We've got 300 every year over 10 years. That's a lot of data, a lot of sites to work with. We've kind of shifted our focus away from thinking about trend estimation, and we're thinking more about understanding the dynamics of the system. And I think that information can also be useful to managers. In addition to the trend, we can give you the trend estimates as well, but I think having an understanding of what's going on is important as well. We're using a lot more sophisticated models and much better covariates. And so what I would encourage anybody to do in a monitoring program is think about what you're doing. Be willing to modify what you do. Don't continue to do what you did because you did it before. Think about improving that monitoring program over the long term, and it will pay dividends. And with that, I want to acknowledge all the other folks that have been involved in this project. Certainly the parks for being such great hosts to the field crews, without which I wouldn't have any data to work with. MPS and USGS has supplied funding, and the College of Business at New Mexico State has supported me in working with the parks over the past decade, and I appreciate that. Thanks. I'll take any questions.
Actually, we have time just for one question, so who would like the last word, please?
Not so local. Or softball. Law.
I got it. I understand what you're saying.
How are things? What are the trends?
You know what? I'm prepared for that. Seriously, prepared for that. For those two species, they've had upward trends. Really, salamanders in the last 3 years, and I'm attributing that maybe to the Andy Ray effect. So there's a change in personnel. He likes salamanders, and that may be simply as a result of somebody trying to pay more attention to that. I don't know. Don't know the answer to that. Spotted frogs are essentially flat, and they're a lot less variable. So spotted frogs are longer-lived species, and they seem to be less reactive to these environmental changes, which I think is also an interesting take-home component of this. But yeah, that's what you add more data, you get different trends then. So
Great work.
thanks.
Well, with that, let's thank all the speakers.